All right. Let's go through question 1. Calculate the limit as x tends to infinity of sine e to the power minus x and explain why this is true. Can someone tell me the answer? Yeah, question 1. Yep. 0. Ashish, why is it 0? Yeah, that's the first step. Signs of 0 is 0. Yeah, that's a good attempt, but there is another, there is a little bit detail which is missing. One important part. Yeah. No. So this is the concept of a limit of composite functions. So there is a theorem which states something about limit of composite functions. Can you remember that? Okay, I can give you a hint. Go to your course reader, page 104. Look at page 104. What is missing in your answer? Anyone? Okay, that's the function sine e to the power minus x is x tends to infinity, is approaching 0. Okay, someone gave me the answer 0, which is very good. Okay, but on this page, page 104 of your course reader, there is a little bit more information why this is true. Can someone tell me? Did you guys look at it? Okay, in that on that page it says limit of a composite function is like let's say if you have limit of your e to the power e to the power minus x is 0 as x approaches infinity. Okay, and then it should say that sine of 0 is continuous. Okay, then you got this one. Okay, so the continuity part should be mentioned. Okay, any question? Is that clear? Okay. Your answer is correct, but there is like this part that the question says, why is this true? That's true because sine of 0 is continuous. Okay. Any question? Okay, let's look at question 2. Calculate the limit of 1 over cos x plus x as x goes to infinity. How would you approach this question? Anyone? Zero. Why? Thanks, Yukun. How would you approach? Like it's 0. Why is it 0? How do you prove this? Yeah, that's a good start. Cos x is between -1 and +1. Then okay. So suddenly jumping from this step to 1 over x. Yep. So if you add a x here, that would be plus x. Would be plus x as well. Okay. And then how do you show from that step? for x bigger than 1, you have yeah. Okay. Okay, what is this concept called? Okay, what's this concept called? Is that intermediate value theorem? See, your function is between two other functions, and on the left function goes to 0, the right function goes to 0, is x goes to infinity. What's that concept? Then what is in between must also goes to 0. It's not intermediate value theorem. Squeeze, thanks, Tripper. Okay, thanks. Okay, if you want to see how this works, it's positive. Let's look at which step are you talking about? If x is negative, that means that you would be multiplying by a negative number. Okay, so that means the inequality sign should change. Okay. Let's look at this. Okay, so the actual function, this is visually how this looks like, the squeeze theorem. If The one in the middle is 1 over cos x plus x, and then on top it is 1 over x minus 1. It should be less than, yeah. Thanks. And on the bottom is 1 over x plus 1. All right. If it is less than 1, then that's a negative number. So that's why. Hang on, maybe I got this wrong. So if x is bigger than 1, that's positive. That's also positive. Yeah. I wrote it as x bigger than 1 because you could multiply by a positive number. Okay. All right. How about question 3? Ah. Oh, question 3. Yeah, that's a good start, Ashish. Using L'Hopital's rule, are you sure?
Attention, following will be a test of the fire evacuation system. These will be test times and test times only. Please disregard. Okay, following will be test times only. Please disregard.
Oh, that's the fire testing. Okay, in this case, you are given a piecewise function. All right, if x is positive, it's sine x over x. If x is, oh, I think I made a mistake, negative. Okay, less than or equal to. Hang on. Yep. Show that this function is continuous for all x. How would you approach this? Using L'Hopital's rule, can you do that? What's the criteria for a function to be continuous? It has to be differentiable. Converge to the same value at that point. Okay, what's the difference between continuous at a point and continuous within an interval? All right, Yan, I think you're on the right track. Show that fx is continuous at x equals 0. Okay, why would we take x equals 0 only? This is a piecewise function. A piecewise function should be continuous in the sub-intervals if it is continuous. So on the sub-interval x is less than or equal to 0, is fx continuous? Okay, check. Yep, Ashish, you're right. So this function seems to be continuous everywhere except 0. So we only look at the continuity at 0. Okay. Except possibly 0, x equals 0. Okay, because sine x is continuous. 1 is a continuous function for all x in x less than or equal to 0, but at x equals 0, the sine x, there is a jump. Okay, so or there there may be a discontinuity, but you need to check this. How would you check it? This is continuous at a point. See definition 12. How would you check if calculate limit x equals 0 for both the function range? That's very good. Okay, take the limit when x approaches from the left and from the right. Okay. In definition 12, it says f is continuous at a point. If f is defined at that point, limit x goes to the point of fx exists, and then limit x goes to the point fx equals f of a. Okay, does all those continuous conditions match? Okay, check. Condition 1. Is f0 defined? Is f of 0 defined? Second condition is check. Yes, it is defined. Yes, f0 equals 1. Okay, second condition is limit. Exist. Okay, third condition is limit. Okay, so are these three conditions satisfied? Then x is continuous at x equals 0. Fx is continuous at x equals 0. Okay, we know that f of 0 is defined. Does the limit x goes to 0 f of 0 exists? Yes, it does exist. And is the limit x goes to 0 f of x f of 0? So to check this, the last condition, you could say you could take limit from both sides. Yeah, Casey, you are right. Okay. Limit from the left, f of x equals f of 0, which is 1, and limit from the right. is sin x over x, which is one from the definition, okay, of that chapter. That means all right. All right. Any question? Okay, if you want to see this function, you can plot it and see whether there is a discontinuity or not. In your quiz, you don't have to plot the functions in Mathematica, but handwritten calculation should be all right. Okay, that's the piecewise function. So on the right, it's sin x over x, and then on the left, it's 1, and then that's continuous. All right, and x equals 0. Any question? Is there any question regarding this? Okay, let's go to question 4. Consider the functions, function fx equals x to the power 4 plus x plus 1. Show that the function does not cross the x-axis. How would you approach this? You may wish to use intermediate value theorem. Or you don't actually need the intermediate value theorem. Okay. Is there any other approach that you can use? Yep, Casey, you are right. So what does this mean? Yep. So find the x value where f dash x is 0. That would give you any critical points. Okay. Let me just write your steps. That's exactly what you need to do. Okay. Okay. If there is just one critical point, then show that, or any other critical point. Show that all critical points are global minimum and it does not cross the x-axis. Or global minimum or maximum, okay? What would be the critical point? What's f dash x? Yeah, second derivative should be positive in that case, yeah? Can someone tell me that critical point? Yeah, 4x cubed plus 1, no real solution. Yeah, which is always positive. Ashish, you're right. Okay. Okay. So f dash x in this case is always positive. Okay. Any question regarding this? Okay, part B, consider the new function. Show that there are exactly two solutions to fx equals 0 using intermediate value theorem and mean value theorem. How would you do that? Okay, what does intermediate value theorem says? Intermediate value theorem, look at page 105. Okay. Mean value theorem. What does intermediate value theorem says? And how are you going to use it? Okay, Shuyan, thanks, Shuyan. A continuous function takes on every intermediate value between the function values fa and fb. What's the condition for fa and fb? Fa not equal to fb. Thanks. Okay, so you have got an interval a and b where fa is not equal to fb, and the function f is continuous in the open interval ab. Then there must exist a number c in between a and b such that f of c is in between f of a and f of b. Okay, so that's intermediate value theorem. How are you going to use that? Remember, show that there are exactly two solutions. Cube root can be negative. Thanks, Casey. Yeah, that's something I missed. Thanks. Right. we're running out of time. Let me share my laptop screen so that I could explain the intermediate value theorem and mean value theorem. Okay, in general, intermediate value theorem I just explained. So if your function is continuous in the interval, open interval a and b, and f of a is not equal to f of b, then there is an integer, a number c between a and b such that f of c is between, this is f of c, between f of a and f of b. Okay, that's intermediate value theorem. How are we going to use that to show that to show that this function has exactly two real solutions? Okay, real roots. First thing is, let's look at 2 points, x equals -2 and x equals -1. At these two values, you have two different numbers. So there is at least one root between -2 and -1. Okay, then let's look at another 2 point, x equals 0 and x equals 1. Again, the value of the function is different, so there is at least one root in this interval 0 and 1. That's what in the intermediate, that's what we gain from the intermediate theorem. We know that there are at least two solutions for the equation fx equals 0. Now use the mean value theorem. What does mean value theorem says? Where is it? Okay, mean value theorem says let f be continuous on the closed interval ab and differentiable on the open interval. Then the slope of the chords joining the points a fa and b fb is equal to f dash, that is the slope of the function at x equals c. Okay, let's see, by the mean value theorem, we know that f dash c is for the interval x1 and x2. First we assume that there are at least three distinct solutions, say x1, x2, x3 in order. Then in the interval x1 to x2, f dash c is given like this. And on the interval x2 to x3, there exists a point D such that f dash D is equal to that. Then that shows f dash x has at least two distinct zeros, but computing f dash x, we get 4x cubed plus 1, equating it to 0, we get just one solution. Okay, so that's a contradiction of the assumption. Okay, so that means there cannot be three or more real solutions to fx equals 0. Okay, does that make sense? Okay, you guys have the last questions. Let me go through it. You are given a series asked whether this is convergent or divergent. Okay, what do you think? The first question. Divergent, maybe. Why maybe? What sort of test are you going to do? Thanks, Ashish. Point diverses. I'm not sure what does this mean. Perhaps you could apply the p-test, where This is also in your lecture notes where the series with 1 over NP, if converges if P is bigger than 1, diverges if P is less than or equal to 1. So I've written it as 1 over N, that's your P, which is negative, less than 1. So diverges, okay, by the P test. Part B, you got pi minus e to the power n. This is equals, this is just number, okay, in the form a to the power n or r to the power n. Sorry, this is r to the power n, where this number is 0.423. You can compute that. What sort of test does this series converges or diverges? I think I've given the answer, geometric, yeah. You could apply the geometric series concept. So in general, geometric series has 8 r to the power n. The series converges if r is in between -1 and 1, or diverges otherwise. So in this case, your a is 1, r is 0.423, which is less than 1, so converges, and it converges to a over 1 minus r. That's 1 over 1 plus e minus pi. Okay, is that clear enough? Any questions? Any questions? Okay, if no questions, I can give 1 more minute for questions. All good? Okay, then thanks very much and good luck for your quiz 2 next week. Okay.